Hello and welcome to a Maths with Harry lesson. In this video, we're going to be having a look at regions. Before we get into any maths in this video, we need to know what a region actually is. Now, in the previous videos, we've been having a look at solving inequalities. And in the last video, we had a look at how to use a graph to help us solve inequalities. Now, a region is a part on the graph where an inequality is satisfied, okay? So that's what a region is. It's just a part of a graph. So I write it here, part of a graph where, it can either be one inequality or it could be many inequalities. So what I'll put is inequality, and I'll put an S there for plural as well, is satisfied. Okay, so you could have one inequality or you could have many. And if you've got many, you need to work out which part of the graph to take so that all the regions are satisfied. You might have done a little bit of this at GCSE, but we'll have a look in this video. So let's have a look, and let's say we have got the inequality y is less than f of x, okay? F of x is our function. We've done a video on functions. Our function could be a straight line. So it could be something like 2x plus 3. Or it could be, well, what else have we seen? We've seen quadratics. So it could be x squared plus 6x minus 10 or something like that, okay? So what we're wanting here is this inequality, y is less than f of x, and we're asking what does that represent? Well, that represents the points, something above the curve, y is equal to f of x. Now again, it might not be a curve, it could be a straight line, but we're taking here that it's a curve, okay? So if we want, well, we've got this inequality, the points that represent this inequality are either, I'll give you two options, above or below this curve, okay? Now we had a look at an example like this in the previous video, and because we want all the points that are less than the curve, we're wanting all the points that are represented by the points that are below the curve, okay? So all the points that are below the curve, and that's because we want less than the curve. So the other option then is, well, what happens if we've got y being greater than f of x? What does that represent? Well, that represents, if we've got below for being less than, it represents all the all the points above the curve, okay? Because we've got greater than. So let's have a look here at two examples. I've got one quadratic here. I've done it as a dotted line just so we can see the shape of the quadratic. And then there's two sections to this graph. Remember, the quadratic will continue like that forever and ever. It will go off the page. So there's kind of two parts on this graph, on the axes. There's the part that is above the quadratic, and there's a part that is below the quadratic. I'm just going to take those away so it looks a little bit neater. And we can see the yellow part here is this part of the quadratic. Now I'm just going to shade nicely like that. And then it's this part above the quadratic, and also that region continues forever, okay? Now that region there that I've shaded in yellow, that satisfies, well, it's above the graph, so we can see it satisfies this inequality, where y is greater than f of x. And we can actually see that that works. If I choose a point on the graph, let's say there, okay, if I go down to where the quadratic is and I go across to the y, we can see this might have a y value of 1 at the cross there. We can see the point that I chose in the region might have, I don't know, a y coordinate of 5. We can see that that is true. It satisfies this inequality because at this point y is 5. And at that point, we can see on the quadratic, y is 1. And so we know that this inequality is satisfied, okay? And we didn't have to take that point there. We could have took a point here. We can see our y value at that point is much greater than our y value at that point on the curve, okay, just working vertically downwards. So we can see that that region is the region that we want. Now I'm just going to go back because I'm about to shade on the next region, and we can see that the next region is, well, the yellow one was above, so the red region is going to be less than f of x, okay? So this region is where y is less than the curve, and we can shade that in red like that, okay? So it's kind of all of this bit here. Now it's hard for me to shade this perfectly. I've gone over the line or the quadratic a little bit, but it looks something like that. And again, that region is, well, it's infinitely big, isn't it? It's never going to stop. It's going to continue all the way down here. But we can see just on the section of the graph we've got, that is the region. And again, we could take an example. We could take a blue point here on this region. The y value might be, let's say that's -1. And if we work up to the curve, we can see that y value might be something like 3. We can see that this point here is definitely satisfying this inequality. The y value is much less than the y value at f of x, okay, or much less than the point on the curve there. Now, when we introduced inequalities a couple of videos ago, we know, or I told you, that there are 4 inequalities. There's less than, greater than, and then there's the equal versions of those as well. There's less than or equal to, and greater than or equal to. When you're sketching regions or sketching inequalities, it's really important that you use the correct line. What we do is we use 2 different types of lines to differentiate from a equal inequality or just a less than or greater than inequality, okay? So there's 2 types of lines. If we have either of these 2 inequalities, so y is less than f of x or y is greater than f of x, the curve is not included. And the reason it's not included is because we don't have any equals on our inequality. If it was included, we would be able to equal the function, or f of x here, but we don't have that. It's called a strict inequality when we don't have an equals. So it's not included because there's no equals on our inequality. So we're either less than the curve or we are greater than the curve. And for that case, what we use is we used a dashed line, okay? So when you're sketching your graph for your region, okay, and then putting your region on, you want to use a dashed line when you've got just a strict inequality, when you've got less than or you've got greater than. Okay, and the reason for that is because the curve is not included. So visually, we use a dashed line to show that the curve is not included in our inequality. So if we've got this case, we've got equals here. We've got y is less than or equal to f of x, or y is greater than or equal to f of x. The curve is now included because we've got the equals part on our inequalities. So in that case, we want to use a solid line. Now what I mean by a solid line is like a line that I'm writing with here. There's no breaks in the line, so that would be an example of a solid quadratic, okay? We could use something like that to show a dashed quadratic, okay? So it's pretty important that you use the correct types of lines. Okay, let's have a look at the first example. I've switched over to squared paper here to make it easier to sketch the inequalities on the graph here. So, it says on graph paper, shade the region that satisfies these inequalities. Y is greater than or equal to 2. X is less than 5, y is less than or equal to 3x plus 2, and x is greater than 0. What you want to do in an exam, if you had a question like this, was to sketch these absolutely perfectly, because that is what your answer is. The answer is the region. We need to sketch them, and then there's kind of no working out really we can do off the graph. So your graph has to be as perfect as it can be. So what I'm going to do is I'm going to sketch these lines first of all. And I'm just going to first of all sketch them like I would do if it was y equals -2 or x equals 5. And then before I kind of actually put pen to paper, I'm going to think, how does my line need to look, okay? How do I need to draw my line? Is it going to be solid or is it going to be dashed? So remember, it is a dashed line if we have no equals on the inequality, and it's a solid line if we have an equals on the inequality. So here we've got y is greater than or equal to -2. We've got an equals, so it's going to be a solid line. And for this inequality, I'm going to use a red solid line. So we need where y is, first of all, equal to -2. So I'm going to draw that on, and it's going to be kind of somewhere around here. Now, it's not going to be perfect for me there because let me just draw that a bit better. I've not got graph paper, but it's going to be somewhere around there. Okay, now it crosses over my numbers there, but that's all right. And we'll write that on as y is equal to -2, because that's the line where it's equal. We're yet to shade the region on, so we're just going to have y equals -2 there. Okay, then I'll take into consideration which part I need to shade in a minute. Okay, so then we're going to have a look at x is less than 5. So I need here a dashed line, and I'll use a colour. I'll have a dashed green line. It's dashed because we have no equals on our inequality, so we're just going to sketch this now with a dashed line. And I'm going to sketch it as x is equal to 5, and then we'll think about in a minute which bit we need to shade. So x is less than 5. Well, let's do x is equal to 5. That is there. Okay, so we can see that we're going between 4 and 6 there because we want 5. So 4 and 6, there is 5. And underneath there, I'll just write on that is x is equal to 5, okay? Because that's what the line is at the minute. Right, I'm going to do this next one last because it's easy for me to do this one here. X is greater than 0. It's again going to be a dashed line because we've got no equals. So let's draw a dashed line at x is equal to 0. And in fact, I'll do it in a bright blue. So a dashed line along there. That is, x is equal to 0 should go along the y-axis. There we go, okay? So there we've got x is equal to 0, and it's along the y-axis, not the x-axis, it's along the y-axis there, because anywhere along the y-axis we're equal to 0. And it's a dashed line again, because we've got no equals. Now what we need to do is we need to do something with this here. So we need to sketch this line. Now I'm going to first of all think about the y-intercept. That is when x is equal to 0. So x is 0, y is 2. So we'll put this on in a red here. X is 2 is somewhere about there. And then I'm going to think when x is 5, I can sketch a point along this green dashed line. When x is 5, y is going to be equal to 17, because y, if it was equal to 3x plus 2, which is what the line is, we can substitute in 5 into there to give me 15 plus 2 will give me 17. So I can put that on there, which will be about there, something like that. Now if you've got graph paper, make sure you sketch it perfectly. So we need a dashed line here, and I will use a different colour. I'll go with a yellow, and I need to make it dashed. So we can do that one as, oh no, we need a solid line here actually, because it's equal to. Didn't see the equal to there. We need a solid line because it's equal to, so we'll do that one in yellow. And it's just going to go through those 2 points, something like that. Okay, we can see it's going to look something like that. And that's the line y is equal to 3x plus 2. Okay, so I've now sketched on all the points. What I now need to do is I need to think about the region, okay? Now, let's go back to the inequalities. The first one here is the red one. That's the line y is equal to 2, but the region we want is y is greater than or equal to minus 2 here. We want greater than or equal to minus 2, so we need to be above the red line. So we need this part of the region, or the graph there, that's the region for the red line, okay? Then we need to take into consideration the next inequality. The next one is x is less than 5. Here is the equal 5 line, and it's dashed because it can't be equal to 5 here, it's less than. So we need the region that is less than that, and that is, well, think about here, my x values are all greater than 5, so we need these values here. Okay, so it's going to be this region here. Now it might get a little bit confusing with all the regions overlapping, but I will show you how to work out which region you want to kind of have that satisfies all the inequalities. So there's 2 inequalities done. The next inequality that we need to do is we need to think about this yellow one here. So we want it to be less than or equal to the yellow line. Here is y is equal to 3x plus 2. We want the region that is less than or equal to 3x plus 2. So we want below the line, and it's solid because it can be equal to. Now it might be quite hard again to see which region we need to shade, but we will we'll give it a go. And you might be better at this with a pencil, not on an iPad. Okay, the last one is x is greater than 0. Well, that's this part of the x-axis, and so we want this region here. Okay, so we can't really tell much of a difference with the darkness of all my highlighters, but the part of the region that you want to then shade, or maybe label it R if you want to, is this region here, and we'll go red. It's that region there. And the reason for that, just shade that a little bit better, it should come to the red line. The reason for that is because that is the part where all of the regions from each individual inequality is satisfied. Okay, now it should be a little bit better, doesn't go over this line, but if you've got a bit of a more accurate pencil, you'll get a better shading. Okay, so that is the region that satisfies every single one of those inequalities. It is greater than or equal to -2. We've used a solid line. It's greater than, it's less than 5, which is this line here, and that's dash, so that's good. It's equal to or less than the yellow line here, and it is greater than 0, so it's got to be that part there. Okay, you could use arrows on here if you like as well. If I use some green arrows, we could say we need it going this way like that, making all of those arrows. We could then say it needs to be greater than here, this line. We could then say it needs to be less than this line here, and then also greater than this line, and it's this region there. Okay, so the arrows might help you a little bit there. Okay, so that is our answer. The red part is your final answer. And sometimes in exams, you might want to label it R for region. Okay, let's have a look at example 2. So similar one here, but now we're involving a straight line and we're involving a quadratic. And that should not be cubed, that should be a quadratic. Okay, let's put that there. So, pause and have a go if you want to, but we'll work through it right now if not. Okay, so hopefully if you paused, you have got an answer. Let's see whether your region was correct. So I want to get this in a kind of form that I can use to sketch it. There's kind of 2 ways you could do this. You could think about it being on the X and Y axis, or you could rearrange it to be y is less than something. And it would be rearranged, y is less than minus, let's think about this, minus x plus 14 all over 2. So it's going to have a gradient of -1/2 and a y-intercept, or yes, a y-intercept of 7. Okay, now what I'm going to do is I'm just going to plot 2 points of that straight line and then connect them together. I'm going to say, well, the first point is when x is equal to 0. So I would have 2y plus x is equal to 14. And if I say x is equal to 0, that's 2y, I'll write that here. 2y is equal to 14, and so y will be equal to 7. So 1 point, 7 is about there on the graph. We'll plot that there, okay? Then we can say, right, well, there's one point. Let's think about when y is equal to 0. Well, when y is equal to 0, we can just get rid of that term there. X will be 14. So it's going to be that point there. And then what we can do is we can just connect those points together. Now I'm going to do this thinking about whether I need a dashed line or not. And I do need a dashed line here because we've got no equals on our inequality. So we'll do it in a grey dashed line. So connecting those 2 points together will look something like that. And we can see that is our line. Make it more accurate if you've got graph paper, but it should look something like that. Okay, and that is then the line 2y plus x is equal to 14. Okay, we've used a dash line there because on our inequality we're not equal. Okay, here we've got a quadratic now and we need some way of sketching that. Now the quadratic does factorise. So let's say y is equal to that quadratic for the minute and then we will factorise that. So when we factorise we get this x plus 1, x minus 4. That should be correct, which it is. And then we can find the roots. So we can say x is minus 1 or x is 4. Okay, so those are the roots of our quadratic. So we can sketch, we can do these in orange. Here is minus 1 and there is 4. And we can sketch this using a solid line because our our inequality contains an equals. So we can sketch it looking something, and this should turn out neatly. There we go. We can sketch it looking something like that, okay, crossing through our roots there. And I can write that on, that is y is equal to x squared minus 3x minus 4. So now I need to think which inequality, or which region, sorry, is going to satisfy both of these inequalities. Well, we want to be less than the line here, okay, and we want to be, well, y wants to be greater than the curve. So if we get y here like we rearranged, less than the line and greater than the curve. Less than the line is anywhere along this region or anywhere in this region. We can see that is greater than the line. And then we've got to be greater than or equal to the curve. Well, that's anywhere above the curve. And we'll do that in yellow, okay? And then we need to think, right, which part of the graph is satisfied by both inequalities, and that's where we've kind of shaded grey and yellow, and that is, again, we'll do it in red, that's this part of the graph there. Okay, that is less than the line and not equal to the line, that's why it's a dashed line, but it is greater than or equal to the curve, so above the curve, and it's that region there because that's the only part that is above the curve and below the straight line. Okay, so that red part is your final answer for example 2. Now, in an exam, if you did shade all of these regions, make sure it's really clear that this is your final region. So like example 1, you could call it R again if you wanted to. Okay, example 3 is a little bit differently. It's a bit worded differently and we have to do a little different things. Okay, so have a go if you want to, press pause and have a go, and then we'll work through the answer when you're ready. Hopefully you've got an answer. Let's see whether you were correct. So what we need to do here is, well, we don't need to sketch anything. We've already got a sketch, and I've just took this sketch from the book. It's the sketch of two lines. We've got one straight line, or two straight lines, sorry, and one curve. We want to write down the set of inequalities that is represented by the yellow shaded region, this region here, okay? Well, first of all, we need to work out which straight line is which. I can see here that the red straight line runs straight through the origin. And if I rearrange both of these straight lines, so 2x plus y is equal to 0, that can be rearranged to give me y is equal to minus 2x, because what I want to kind of recognise is the general form of a straight line. And then if we do this other one here, we'll have x plus y is equal to 4. That can go to y is equal to, and I'll write it, minus x plus 4. Okay, so which of these straight lines is the red line and which is the blue line? I can see here I have no y-intercept, we've got no c, we've just got a plus 0, which we don't need to write. So it's going to go straight through the origin, this line. And it's got a negative gradient of 2 straight through here, so we can see that this is the red line. So that means if that's the red line, then this one is the blue line. And we can see that as well because when x is equal to 0, we're on the x-axis, and the plus c, which is the y-intercept, is plus 4 here. And we can see it crosses through 4 there. Okay, so our curve is the only curve we've got, so we know it's going to be this curve. And it's a dashed line, so we're not going to have an equals on our inequality. Now we can see this yellow region is below this dashed curve. And so the inequality for quadratic is going to be y is less than 2 minus 5x minus x squared. Okay, we are below, or in the yellow region, we are below the quadratic, so we need to be less than. Okay, so that's one inequality. I'll write that, or highlight it in yellow. If we think about the red line, the yellow region is above the red line. Okay, any point here is, or in the region, any point is above the red line. And it's a solid line, so we're going to be greater than or equal to. Greater because we are above the red line. So that's our first inequality. Y is greater than or equal to minus 2x. And we could also write that kind of how we had it here. That means 2x plus y is greater than or equal to 0. Either of those kind of mean the same thing, so either inequality is correct, and those basically mean the same thing. And then if we look at the blue line, well, we've got the blue line here, this is that line there. We've got the region below the blue line. It's a solid line, so it's going to be equal, and we are below, so we need to be less than or equal. So we need y to be less than or equal to minus x plus 4, okay? And then if we get it in the form like we had up here, we will have, well, add x to both sides. X plus y is less than or equal to 4. And then kind of either of those is correct, but they both mean the same thing, okay? I would give my answer as that inequality, and this inequality, and then that inequality. And they're ands because they all have to be true, or they all are true for this region here.